Good afternoon, everyone. In the earlier lecture, we had seen the detailing for the slab as well as we had seen the how to design the slab. Now today in today's lecture, we are going to see the beam design. So let us start with the beam design of the beam, as well as we had seen this edge strip reinforcement also for the slab. Now we'll start with the design of beam B1. As you know, as we have seen that we are designing for the two-way slab. So as you can see over here, this is for the beam B1. So it is of the size 4 meter by 5 meter, and this is your beam B1. So Ly over here is 5 and Lx is 4. So Ly by Lx ratio is 1.25, or you can say that 5.14 upon 4.15, that is nothing but the thickness also we had considered over here. So it will be also 1.24. So always beta will be equals to 1.25 or 1.24, that is Ly by Lx ratio. So you can draw this diagram and note down the value for beta. So draw this design for the beam as well as note down the values of beta. And after completing, let me know. Okay, completed. Yes, done up till here. Should I proceed with the further calculations? Everyone had drawn this diagram and calculate beta. Okay. Okay, so proceeding further. Therefore, equivalent UDL intensity for the bending moment. For calculation of bending moment, you need to calculate the load. So here you need to calculate W equivalent before calculating bending moment. So for calculation of W equivalent, that is for calculation of W, you are having the formula that is WU into LEX, that is the ultimate load upon L effective in the X direction divided by 2 into 1 minus 1 upon 2 beta square. So already the value for beta you had calculated above. W is nothing but the ultimate load that you had calculated when you had done the designing for the slab. So into L effective in the X direction also you had calculated previously. So just substitute the values of WU, that is 10.875, into L effective for the shorter direction or in X direction, that is 4.15 divided by 2 in bracket 1 minus 1 upon 3 into beta square. So see the value for W equivalent, you are going to get it as 17.67 kilonewton per meter square. And as you know that we are designing for the simply supported beam. So it is a simply supported beam. So just calculate W equivalent, see whether you are also getting the same value or not. After completing, let me know. Yes, done. Done up till here.
Done, ma'am.
Okay. Now the value for FCK is 20 as the grade of concrete is given to you, that is 20 Newton per mm square. Then the value of Fy comes up to be 415 as the grade of the steel is 415. Then LE is nothing but the cross section between the columns. So as you know, the cross section between the columns for this particular problem is 5 meter. So LE is, that is L effective, that is the cross section between the columns is 5 meter. Then you need to calculate XU max. So for calculation of XU max, 700 upon 1100 into 0.87 into Fy. So after calculating, the value of XU max comes up to be 0.48. And after calculation of XU max, you need to calculate Q maximum. So Q maximum is 0.36 FCK into XU max, 1 minus 0.42 into XU maximum. So substitute all the values of FCK and XU max, you will get the Q maximum. So solve up till here. Yes, what is Q max over here? Q max is nothing but the maximum shear stress. The maximum shear stress in your rectangular beam is Q max. See whether you are also getting the same answers or not. See whether maximum shear stress you are also getting 2.759 or not. Yes, done up till here. Should I proceed further? Everyone had completed up till here. Everyone had got the value for
Yes, ma'am.
stress. Okay. So Qmax will comes up to be 2.759 Newton per mm square. Now we need to calculate the load. So let the beam width be equal to the width of the column. As already in the question they have given you the width of column as 300 meter. 300 mm. So beam width will also be 300 mm. And for simply supported beam, let D will be equals to LE by 15. For simply supported beam, the value for the depth will be effective length upon 15. So for this effective length is 5 meter, that is 5000 mm. So D will be 333.33. So overall depth you have to provide it as 350 mm. So complete up till here. Then we'll proceed for the calculation of loadings. And after that we need to calculate the bending moment also that will act upon the beam. Yes, for simply supported beam, the value for depth is LE by 15. It is from the IS code. From your IS 456-2000, D will be equals to L effective by 15. Wait, I will let you know. First you solve this, I will let you know if you. It is for simply supported beam. For minimum height they are taking L as 20. That is for the minimum height they are considering it L by 20. For depth you have to take it as LE by 15 for simply supported beam. L/20 जो बोला था, that is for the minimum height, and that is for the slab, for minimum height of the slab. And for beam, for simply supported beam, D will be equals to LE/15. And for minimum height for simply supported beam, it is L/20. Okay, done up till here. Should I proceed further? Yes, Saurabh completed. Rita.
Yes, ma'am, completed.
Okay. Now loads on the beam per meter. So for calculation of loading, you need to calculate first of all the self weight. So for calculation of self weight, you need to multiply it by width, that is 0.3. We have taken 300. So as we are converting it in meter, so it will be 0.3 into depth, that is 0.35 into 25. So the self weight will comes up to be 2.625 kilonewton per meter. And after calculation of self weight, you need to calculate the factor self weight. So for calculation of factor self weight, you need to multiply it by 1.5. So 1.5 into factor self weight, you will get 3.9315. Then W equivalent is your 17.67. So total W will be your 21.60 kilonewton per meter. So in this way, you will get the total W, total load, that is 21.60 kilonewton per meter. So calculate this total load, see whether you are also getting 21.60 or not. Okay, completed. Everyone and got the answer for W, that is 21.60 kilonewton per meter. Okay. So after this, you need to calculate the bending moment. So as you know, the length is 5 meter. So the total load acting upon your length of the beam, that is total length, that is 5 meter. So the design moment, the formula to calculate the maximum bending moment is WL square by 8. So W already you had calculated, that is 21.60. Effective length is your 5 square by 8. So you will get the maximum bending moment, that is 67.50 kilonewton meter. Then you need to calculate D required. So for calculation of D required, you are having the formula, that is MU limit will be equals to maximum shear stress into B into D square required. So substitute all the values for bending moment as well as the shear stress. substitute the value of B, that is 300. Then you will get the D required, that will comes up to be 285.57 mm. So solve up till here. Calculate the value of D as well as the moment. See whether you are also getting the same answers or not. And if any doubts, you can ask. As everyone had got the values for moment, that is 67.50 kilonewton meter. After calculation of movement, calculate the depth required. Required depth. Okay, everyone had got the answer for depth and moment. Should I proceed further? Yes, done. Yes, had you got the answer? Should I proceed further? Okay. So as everybody, depth required is 285.57 mm. So provide overall depth, that is 350 mm only. Then you have to assume 16 millimeter sorry. Sorry. You have to assume 16 millimeter diameter bars and 8 mm diameter stirrups. So you will assume 16 millimeter diameter bars and 8 mm diameter stirrups. So effective cover will be your clear cover per stirrups diameter plus 16 by 2. So clear cover you are going to take it as 20 over here. Stirrups diameter you are going to assume it as 8, and 16 millimeter diameter bars you are going to assume. So 16 divided by 2, that is again 8. So effective cover will be total 36. effective cover will be 36 mm. Then you need to provide D, that is 350. Already you had provided D, that is 350 minus effective cover, that is 36. So it will comes up to be 314 mm. Then you need to calculate the reinforcement for the main steel as well as for the secondary steel. First of all, do up till here. Calculate the effective cover and provide D. Yes, all of you had completed up to here. Should I proceed with the reinforcement steel for the main as well as for the secondary one? Okay. So for the main steel, again you need to calculate the reinforcement. And for calculation of reinforcement, again you are going to use the same formula that you have used this in for the slab. That is 50 FCK by Fy into 1 minus under root of 1 minus 4.6 mu upon BD square FCK. Now here, as you know, the FCK is 20 and Fy is 415 as the grade of the steel is 415. Now substitute the values for movement so that you had got. So the value for movement you had got is 67.50 into 10 raised to power 6 upon B. B is here 300, D is here 314. So substitute the value of D, that is 314 square, and FCK is 20. So gamma T, that is for percentage, you are going to get it as 0.748%. Then you need to calculate the AST. So for calculation of AST, you need to, you are having the formula that is gamma T into BT by 100. So substitute the value of gamma T that you have got just now, that is 0.748 into B, that is 300 into D, that is 314 by 100. So AST आपको मिलता है 704.616 mm square. Before that, calculate gamma T percentage. Substitute the values of moment and width and depth. And if you are having any of the doubts, you can ask. Okay. What about others? All the others are also done. Should I proceed further? All the others are also completed. Okay. So AST आपको मिलता है 704.616 mm square. Then you need to calculate the number of 16 millimeter 5 bars. So कितने number of bars आपके आ रहे हैं that you need to calculate. So as you had used 16 millimeter diameter bar, so AST upon 5 by 4 into 16 square. That will comes up to be 3.50. That is approximately will be equals to 4. So you need to provide 4 bars of 16 millimeter diameter. Then you need to calculate AST provided. So for calculation of AST provided, आपको number of bars कितने मिले हैं? Number of bars comes up to be 4. So 4 into pi by 4 into 16 square. So AST provided, you will get it as 804.24 mm square. So calculate AST provided. Okay. Now you need to check for the width. So for checking of the width, you 4 number of bars is being provided and the 25 millimeter space is being given between each of the bar. दोनों भी बार के बीच में 25 mm की space we are going to give. So required width you will get it as 4 into 16 as 4 into 16 bars is being provided to you plus 5 into 25. अब ये 5 कैसे आया? Because हर एक इसमें 5 see 1 2 3 4 and 5 ये नंबर ऑफ स्पेस आपको कितनी बार देनी है? 5 बार देनी है. 5 बार आपको स्पेस देनी है और वो कितने की देनी है? वो कितने mm की स्पेस आपको देनी है 5 बार? That is of the 25. We had assumed it as 25 and number of bars are 4 and the diameter of the bar is 16. इसलिए we had multiplied it by 4 into 16 plus 5 number of space is there and 25 mm space you need to provide. So it is 189 mm. So it is less than the 300 mm that is the width. So our design is safe for the width. So do up till here. Then we need to do for the next check, that is for the shear. Okay. All the others are also completed. Yes, reply fast. Okay. Then you need to check for shear. So as the beam is provided with two leg, 8 mm stirrup set, 150 mm center to center throughout the length, you need to check it for the deflection. So 1 by D actual will be equals to 5000 by 314. So 5000 is nothing but the length and 314 is your depth that you had calculated in the previous step, that is 314. So that is 15 by 92 and L by D basic will be 20 according to your IS code. So first of all do up till here, then we'll proceed further. Yes, done up till here. We are having last 1 minute. As L by D basic is our 20. Therefore, our design is safe for the deflection. Now we need to do the check for the development length, but we are running short of time. Last 1 minute is there. So those who are not given the attendance, give your attendance in the chat box. And by tomorrow, we will complete this design of beam and we'll start the next sum for on this same topic. Now the check for the development length is remaining as well as the detailing part is remaining. We'll complete by tomorrow. And if you are having any of the doubts up till here, till the deflection step, you can ask.